Hey guys, we're here to talk about transformations, part 1, exploring vertical transformations. Let's get started. Here's a picture of the original graph, y equals f of x. This is the graph that we will refer to throughout the process of performing all of the transformations. One suggestion I would make is to draw in your points the same way that they're drawn here. To the right of your paper, we have a table for this graph, and we need to fill in the corresponding y values for our x values. So I see that whenever x is -4, the corresponding y value is going to be 3. X is -4, corresponding y value is 3. So I put 3 in my table. When x is -3, the corresponding y value is 0. So I put 0 in my table. And then when x is -2, the corresponding y value is -3. Go ahead and pause the video, fill in the rest of the values, and then press play to check. Okay, so these are the values that you should have gotten. Let's go ahead and move on to the next one. All right, so here's our first transformation, and it has y equals f of x plus 2. Again, we have the original function because that's the one that we are transforming. We want to create a table with the domain and range values. So I'm going to use the original values from our first page. So this is where we're starting. Now we are going to transform these values by adding 2 to each of the f of x numbers. So here we have it. When I add 2 to each of the y values, these are the corresponding values for my new graph. So this is what I started with. Now go ahead, pause the video, plot your points. We want to make sure everyone understands how to plot their x and their y values correctly in the correct quadrants, and then press play to see if you've done it correctly. Here's the new graph. How will we describe this transformation? The function has a vertical translation by 2 units. Another option you could say is the function has been translated up by 2. Okay, so let's look at the next one. It says y equals f of x minus 2. Let's see if we can do this without a table. Well, the previous one said y equals f of x plus 2, and we noticed that it translated up. So what do you suppose will happen here? Here's the original graph. And here's the new graph. Notice that my transformed graph is below the original graph. So how would I describe this transformation? The function has a vertical translation by -2. So if you need to check the table to understand what happened, notice here that I decreased all of the f of x values by 2 based on my rule. As you're moving through the video, if you have any questions, be sure to write them down. Also, I would suggest graphing your transformed graph in a different color, just so that it stands out more. Okay, here's another transformation. This one says y equals 2 times f of x. So we want to create a table with the domain and the range values. Here are the original numbers. How will we transform the new ones? Very good. We'll need to multiply all of the values in the f of x column by 2. Okay. So go ahead, plot the new points, and then write the description for the transformation. Okay, hopefully this is what you got. If not, go ahead and make the corrections and plot your points correctly. The vertical description. The function has a vertical dilation by a factor of 2. You also could describe it as the function has a vertical stretch by a factor of 2. Okay, here's the next transformation. Y equals 1/2 times the f of x value. Okay, so let's take a minute, pause the video, and see if you can perform this transformation. Don't forget to write down your verbal description. If you need to make a table, that's perfectly fine. Go ahead and make a table to assist you with your transformation. Remember, the function rule is y equals 1/2 times the f of x value. Okay, so hopefully this is what your picture looks like. And here's the description. The function has a vertical dilation by a factor of 1/2. The fifth transformation says y equals negative f of x. So just like before, we're going to make a table and use our original range values. Now, since I have a negative on the outside of that f of x, what do you think that means? Very good. We're going to change the sign. We're going to multiply each value in the f of x by -1. So let's write down our new range values. These are the values that you should have gotten when you perform your transformation. Here is the graph. What's the verbal description that goes here? The function has a vertical reflection across the x-axis. Remember to pause the video or replay anything so that you can make sure you understand the concept. Moving on to the next one. All right, so our next transformation says y is equal to the absolute value of f of x. Well, what does absolute value mean? Go ahead, take a minute, create a table if necessary, and perform the transformation. Press play when you're ready to see the resulting graph. Here's the picture that you should have gotten. So we're back to the very first page, and this transformation was below our original graph. Can you tell me what transformations are taking place here? We have 3. It moves down the graph 1 value, it increases its height by a factor of 2, and the graph flips or is reflected over the x-axis. When we perform our transformations, we perform them from left to right. The function has a vertical reflection across the x-axis, a vertical dilation by a factor of 2, and a vertical translation by -1. If you have any questions, please remember to note them in your notes, and we will discuss them in class. Thanks for watching.